All right, guys, so here is the isotope egg activity follow-up. So you should have collected all your data. You should have put your data in this chart. All of that should be done. And then once you've gotten approval, then you're going to go ahead and fill out number 8, making sure that you're waiting until I've said all data is collected. Basically, once all periods have recorded their data and I've approved their data. Okay, so then comes this, and this is a talking question. These, I would definitely talk with your lab mates and think about what makes sense. Think about what we learned about protons. Do they have mass? Where are they? How many of them are there? What do we know about neutrons? Do they have mass? Where are they? What do we know about electrons? Do they have mass? Where are they? To answer these questions. So which one do you think the beads represent? There's one of 3 choices: protons, electrons, or neutrons. Same thing. And same thing. So you're trying to figure out which ones they are and explain why. So I definitely talk to your lab partners about those answers. And then this asks for the average mass for all your class periods. That's that whole adding F2 and J2 and N2 when said. So once you steal that information from either here or from your page here, if you've already written it down, it wants you to put it here as well. Then you're going to compare it to your average. So you need to put your average here. Well, where do you find your average? The same place, except for not F2. Now you're going to actually find your name. So I'm going to take, let me scroll over a little bit. I'm going to take this value, so my F column, where my name is, which is 1, and then my J column, which is so it's like the second red column, 1 plus 6.6 plus 3.6. That's going to be my number, okay? So once you get your numbers filled in, you're stealing the F column, the J column, and the N column for your data, okay? So that's what's going in here. Make sure you write it in. And you're going to compare. Is it the same value as the average for all the classes or different? And why do you think so? So make sure that you write your number and then also explain if it's same or different and why. And then this part is just Googling the periodic table on the internet, and then according to how many protons we have, and you should have figured out based on whether or not those are pennies or black pennies or beads, what element are we looking at? Record that atomic mass down. Google what isotopes are used for in these 3 areas. And then you probably are okay to move on to this, or just make sure that I have a conversation with you or you watch this video for this next part. Okay, so because you will get this wrong if you don't kind of watch this video or have me talk about it in person. So mass number and average atomic mass, what are the difference? Mass number is when we count up the mass in one egg. That one atom has that exact mass. But if we looked at all the atoms on the planet, it's not going to have that exact number. We've already looked at how different eggs had different masses. And so the average atomic mass basically takes all of the atoms on Earth and averages those mass numbers. And that's how you get on a periodic table, for example, carbon is like 12.011 or whatever. That's how you get that kind of non-whole number, because it's the average of all the atoms on Earth. Whereas when we look at one atom, it's going to have an exact mass number. You can't have 2.1 protons, right? You can't have 2.1 neutrons. You can't have 2.1 electrons or whatever. You have to have either 2 or 3 or whatever it is. And so that is what we're talking about. When we're looking at a mass number, that is representative of one atom. When we're looking at the average atomic mass, we're looking at all of the atoms on Earth and averaging their masses out based on how common they are. That's it for today. That should take you through all those questions.